Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Functions make up almost 1/4 of the test questions. Standard 8.F.3. Define, evaluate, and compare functions. Interpret the equation y equals mx plus b as defining a linear function whose graph is a straight line. This standard is very important. 2 to 4 questions are on the test every year.
Hello and welcome. Here is what you need to know before we get to the examples.
What is a linear function?
A linear function is a function whose graph is on a straight line or is a straight line.
Y equals mx plus b.
Is a linear function whose graph is a straight line where m is the slope, rate of change, b is the y-intercept where the line crosses the y-axis.
Examples of nonlinear functions.
Functions that contain x squared or x cubed or 1 over x or x to the power negative 2, any power of x different than 1 makes it nonlinear function. So remember that any power of x different than 1 makes it nonlinear function.
Functions given by a set of ordered pairs.
Sometimes functions are given by a set of ordered pairs, and we need to see if those points are on the same line. So you can we start with a situation where I have 3 points, A, B, and C. You calculate slope of AB and slope of BC. If they are equal, then A, B, and C are on the same line. Given 4 points now, A, B, C, and D, you calculate the slope AB, slope BC, slope CD. If they're all equal, then A, B, C, and D are on the same line. So we refer to this as constant rate of change. Constant rate of change makes the function linear.
Linear and nonlinear functions will be studied in the following examples.
Example number 1, a graph passes through the points 0, 0, 1, 2, and 2, 5. Which statement about the graph is true? It's linear because it passes through the origin. It's not linear because it passes through the origin. It's linear because a straight line can pass through the given point. It's not linear because a straight line cannot pass through the given points. Now you notice here these first 2 options really have nothing to do with the graph being linear or with the function being linear or not linear. Has nothing to do with that. So here's an example where here's a function. It's not linear. It's not linear, even though it passes through the origin. So it has nothing to do with that. On the other hand, this is a linear function and it passes through the origin. So what? So these 2 options are not valid at all. So now you have 2 possibilities. Either the lines are a line passes through the 3 of them, or it doesn't. Therefore, we can determine whether the graph, whether these 3 points, whether the function is linear or not. So I draw here. You can draw here the points. This is 0, 0, 1, 2, and 2, 5. So if I draw a line between the first 2 points, I see it doesn't go through the third one. So my answer would be it's not linear because a straight line cannot pass through the given points. Now that requires really making careful about how to draw these points. Now what you can do also, you can calculate the rate of change. 3 over 1, rise over run, 2 over 1, and 3 and 2 are not the same, then this is my answer. Example number 2. Again, every time you see this picture, you may pause and solve the problem and come back and check your answer. Which graph represents a function that is linear? Linear. So reminder, a linear function is a function whose graph is a straight line. Is this a straight line? No. Is it a straight line? No. Is it a straight line? No. So that's your answer right there. A question like that is really easy, and don't lose a question like this. Example number 3, 4 functions are shown. Which function is linear? When you look at these options given to you, obviously this one does not work because x squared. It's not linear. Remember when I earlier said x squared makes the function not linear, so that doesn't work. And this one obviously is not a straight line, so A and D are not linear. Now you're left with option C or option D. I'm going to start with option C. Here 3 points are given. We need to see if they are on the same line or not. So let's calculate the rate of change. 1 minus 5 over 0 minus 2. Here now 5 minus 1 over 2 minus 0. So now here this is 2. Here this is negative 2. And they are not the same. They are not the same. So C is not linear. C is not linear, cancel it. Now, this is the option left for me, which is the correct answer. But let's do some work here. I'm going to find the rate of change. So 1 minus 1 is 2. 3 minus 1 is 2. 0 minus 3 is 3. 3 minus 0 is 3. Now look, 2 divided by 3, they're the same. They're the same, and therefore the answer is B. Question number 4. Which graph represents y as a linear function of x? A linear function of x. When you look at those here, for sure this one is not good. This one is, I mean, it's not linear, okay? So you can say this option here. It's not linear. This one here is also not linear. You cancel it. Now, here's the confusion that students might make. This is a line, straight line, but this is not a function. This is not a function, so you should not consider this. And the only option left is A. So again, a linear function is a function whose graph is a straight line. Note that B is not a function, and the answer is A. Example number 5. Which graph represents a linear function? The same as before. This one is not linear, obviously. This one is not linear. This one is not a function. And this is the only option left for you. The answer is D. Example number 6. This is a little bit different. Which table represents a linear function? So here is the functions are given pairs of numbers here, 9 and 9, negative 8, 8, negative 4. Okay, so pairs here. So we need to find the rate of change of each one of these here and see which one is constant. That's what we are looking for. That's what we are looking for. So the rate of change must be constant. Okay, so let's start with A. Where did I get this 2 from? 3 minus 1. 1 minus 3 is minus 2. 3 minus 1 is 2. Here we're going by 1. So obviously it's not, the rate of change is variable. This is 2 here, this is minus 2. So this is not an option for you. Let's see the next. Yeah, that's 1, 1, that's constant. So that's the correct answer. Now let's double check the other two here. We'll see what we have. 4 divided by negative 1 is not the same as 2 divided by negative 1. So that's also a nonlinear. The last one here, 1 divided by 1 is 1, 2 divided by 1 is 2. They're not the same. That's a variable rate of change. So that's also is not good, okay? Okay, now, all right, now, question number 7, which table represents a nonlinear function? It's very important that on the test to read the question carefully. Here is asking you nonlinear. We need to find the table where it has a variable rate of change. So the rate of change must be variable, not constant. So let's check one at a time. Here I get 2 over 2 is 1, 1, 1. That's actually linear, so that doesn't work for me, okay? Next. What happened to my cursor again here? Okay. Wait for the cursor to reappear. Oh, here it is. Now the next is this one here. B. So 12 divided by 4 is 3, 6 divided by 2 is 3, 9 divided by 3 is 3. This one is also not good, okay? I don't know why every time I use the pen it disappears, the cursor disappears. All right, so now we're going to the third one here. Where is the, here's the cursor, here. This one here. Again, the same thing. Minus 6 divided by 3 is minus 2. Minus 2, minus 2, that's also constant rate of change. So that's also not good. So that's not good. So I'm left with only one, which is this one. Let's see what happens. 12 divided by 2 is 6. 36 divided by 2 is 18. 48 divided by 4 is what, 12? So you see it's variable rate of change. So that's your answer. That's the one which is nonlinear. The last question is really easy. Select all of the equations that represent a nonlinear function. Again, read the question carefully. Select all. It means there might be more than one good answer. Nonlinear. Okay, so if I look at the first one here, it contains x squared, so that's good. That's nonlinear. I choose this. The second one is linear, so I don't have it. I don't need it. The third one is also linear because that's 2x plus x is 3x. This one here is actually 3x squared plus 10x. So it contains x squared. That's nonlinear, so that's a good option for me. The last one is not good, is linear. Is linear because that's 1/3 x plus 10. And that's it.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.